Hi there, erosion and sediment control enthusiasts. This is Dagan Blakely speaking to you today on behalf of the Alberta Erosion and Sediment Control Association. We are a professional organization dedicated to promoting and furthering education in the field of erosion and sediment control in the province of Alberta. This presentation is the first in a series of short tutorials on our new YouTube channel to introduce you to concepts for the design, installation, and inspection of erosion and sediment control measures, as well as the basics of erosion and sediment control. Today's topic is on how to calculate appropriate ditch check spacing. In this video, I will cover where ditch checks are used, some typical ditch check products, and how to calculate the spacing of your ditch checks. As a bonus, I will also provide a couple of field installation tips for installation of ditch checks. Ditch checks are typically used to protect areas where concentrated runoff flow is expected and the vegetation has been removed, exposing bare soil, such as in a ditch or drainage swale. The photo on the right shows a newly graded and topsoil ditch where vegetation has yet to become established. Ditch checks have been used here to reduce erosion and promote sedimentation until the vegetation can become established. Ditch checks work by ponding water behind the ditch check. The increase in water depth due to ponding in turn slows the velocity of the runoff. With a slower velocity, the erosive force of the runoff is reduced, so fewer soil particles are picked up and carried in the flow. As you can see in the second photo, slowing the flow velocity also makes soil particles settle out of the flow, as in this case, where the silty material has dropped out of the flow and settled out on the upstream side of the ditch check. Ditch checks are predominantly used in situations where runoff is intermittent, allowing for periods of vegetation establishment in between runoff events, and would not typically be used in permanent creeks or rivers. A range of products can be used for ditch checks. Rock, riprap, or Engabion baskets or mattresses could be used for more permanent installation in areas where slopes are steeper and vegetation establishment is more difficult, as the ditch check will be required over the long term to provide erosion protection. Sediment control logs and geosynthetic barriers could be used as an interim measure until vegetation has become established in the ditch or swale bottom, with the vegetation providing for more permanent erosion protection over the long term. Sandbags could be used for a temporary installation to mitigate against erosion in a ditch prior to ditch reaching final grade, and prior to the application of topsoil and seed. Ditch check spacing calculation. It can often be left up to the crews in the field to determine how far apart to place the ditch checks. But as an erosion and sediment control designer, you really should specify the ditch check spacing on your erosion and sediment control measures drawing to ensure that the ditch checks function properly, as well as to ensure that sufficient ditch check supplies are brought to site. To calculate the ditch check spacing, you will need to know the slope of your ditch. This is typically determined from the construction drawings for your site or by field surveys of existing conditions. The slope is calculated as the difference in elevation over the horizontal distance. For the purpose of our ditch check spacing calculation, we will use slope in the units of meter per meter. If the slope is given to you as a percentage, you can determine the slope in meters by meter by dividing the percentage value for the slope by 100. The second piece of information you'll need is the height of your ditch check. For checks made of rock or sandbags, it will often be the designer that specifies the height of the check. For manufactured products, you can refer to the manufacturer's specifications for the height as well as for installation procedures. If you plan to trench in your ditch check, you'll need to reduce the height of the check by the depth that is trenched in. For example, if a 0.4 meter tall rock ditch check is trenched in by 0.1 meters, you would use a height of 0.3 meters for your ditch check calculation. Once you know your ditch slope and ditch check height, you can calculate the spacing of your ditch checks so that the top of the downstream ditch check is at the same elevation as the toe of the upstream ditch check, ensuring that during a runoff event, the water will be ponded back along the entire reach of the ditch. The ditch check spacing in meters will be equal to the ditch check height in meters divided by the ditch slope in meters per meter. Here is an example calculation for spacing of straw wattles used to stabilize a regraded highway ditch. In the first step, we look at the construction site plan drawings to determine that the ditch slope drops 4 meters over a distance of 224 meters. So our calculated slope is 4 divided by 224, which equals 0.018 meters per meter. Note that if your ditch doesn't have an even slope, you may have to calculate more than one ditch check spacing for your project based on the range of slopes on site. In the second step, we review the manufacturer's information for the straw wattle product we've specified and determine that it has a diameter of 30 centimeters or 0.3 meters, which will also be the ditch check height. Next, we calculate the ditch check spacing for our site by dividing the ditch check height of 0.3 meters by our ditch slope of 0.018 meters per meter to get a spacing of 16.7 meters. This is the spacing that we need to ensure that the crest of the downstream ditch check is at the same elevation as the toe of the upstream ditch check. This information could then be added to the erosion and sediment control measures installation drawing, so the installer on site knows how far apart to place our straw wattles. Now that you know how to calculate the spacing of ditch checks, here are a couple of installation tips to watch for in the field. Number 1, make sure the ditch check is contacting the ground so that no flow can get underneath it. This may require trenching the product in or ensuring enough stakes are used to hold down the product on the slope. Number 2, make your ditch check smile. You need to ensure the ends of the ditch check are installed high enough up on the ditch slope so that any spill during a runoff event will go over the middle of the ditch check versus bypassing the ends of it. And it looks like it's been installed in the shape of a smile. A height difference of between 15 and 30 centimeters should work in most cases. So to summarize the key points from today's video, ditch checks are used in areas of channelized flows, like roadway ditches and drainage swales, to reduce flow velocity and in turn erosive forces, as well as promoting sediment dropout from the runoff. Ditch checks need to be spaced appropriately to function. If they are too far apart, you won't achieve the runoff velocity reduction benefits. And finally, correct installation of ditch checks in the field is key to having them function properly. You want good contact with the ground, and don't forget to make them smile. I hope you have enjoyed today's video on the calculation of ditch check spacing. Please check back on this page for future video content or have a look at our website at escab.ca for more information on the Alberta Erosion Control Association.